Hi, everyone, and welcome to our session on putting chaos into continuous delivery, how to evaluate and increase the resiliency of your applications. My name is Juergen. I'm a technology strategist at Dynatrace and a maintainer of the Keptn open source project. And today I'm joined by Karthik. Hi, Karthik.
Hi, Juergen. Hello, everyone. I'm Karthik. I'm one of the maintainers of the LitmusChaos project and a co-founder at ChaosNative. Great to be at CDCon.
So let's jump directly into the topic. We want to get started with the typical CD process. I think that's a perfect theme for this kind of conference. And in the typical CD process, what we see is our applications, they move from earlier stages like a dev environment to all the way to production. And of course, during the deployment or after each stage, when we pass from one stage to the other, we want to have some kind of evaluation on the quality of our services and applications. We usually do this by using performance tests or load tests, and we make a decision. Our apps go all the way to production, but we can never be sure that nothing is happening in production, nothing bad is happening in production. So there is always something that we cannot really test, either because maybe we don't have any tests, or because we are depending on some third-party services, or of course we are depending on some kind of networking or some kind of infrastructure. So there might be some issues in productions that we are facing. And I say there might be, but we all know there always are some issues in production. And the idea of today's talk is to use those issues, to use those unforeseen issues and troubles we are facing in production and introduce them already early on in previous environments and shifting left by introducing chaos in early stages to be able to evaluate the resilience of our applications. And we will be using a lot of open source tools in this presentation. We will be using open source load testing, open source chaos engineering, open source orchestration of the whole workflow. So there is a lot to come, but to learn more about how we can evaluate the resiliency, I'm handing over here to Karthik to introduce us to chaos engineering.
Thank you, Juergen. I think a lot of folks are already aware of chaos engineering. We can just go over it briefly. So chaos is a way to inject controlled failures into your environment and verify the application or infrastructure behavior so that you are guarded against outages that might happen. So you are inducing failures intentionally, deliberately, with a very solid hypothesis around what might happen when you inject those faults. And depending upon how the system actually behaves, depending upon whether the hypothesis is proved or disproved, you go ahead either to the next fault to verify system resilience, or you go back to the drawing board to fix your infrastructure or your business applications. It is like vaccination. We are in the time of the pandemic today, and it is a good analogy. We are basically injecting harm to ensure that we are immune from outages in the future. So while chaos engineering has been traditionally practiced with a shift right mindset, it has been done in production. There has been a long revolution around testing in production. We are seeing in the recent times that there is a left shift as well. People are running chaos in pre-prod environments as part of their continuous delivery pipelines. And one of the reasons for that is because of the cloud native paradigm. People are moving to Kubernetes as the deployment platform of choice. And when you run your applications, which most probably have been re-architected to be microservice oriented, when you're running them as deployments on Kubernetes, you're typically exposing yourself to a lot of points of failures. For example, in this diagram, you see that there are the platform services, your bare metal or cloud. The Kubernetes services themselves, the Kubernetes control plane itself is quite dense. You have a host of tools from the cloud native ecosystem that you're using for service discovery, observability, for storage. Then you have your direct application dependencies like databases, then you have your application. So what this means, and then your application itself, it could be the front-end user-facing part, the middleware, the back-end services. So what we're trying to say is the resilience of your application also depends upon a lot of other infra components in your deployment environment. So it is necessary that you inject failures willfully and identify what are the different points of failures, and when failures do occur there, how your application responds. So in chaos experiments, you run the experiments with a hypothesis, or this is how your apps might behave, your infra might behave. But not only you go with knowledge of what might happen or what should happen, there are also things you learn along the way. So chaos engineering is also about learning unknowns. You might have built your applications assuming certain qualities of your deployment environment. You might assume the network is always reliable, the latency is zero, you have infinite bandwidth, there's abundant compute and storage resources, but that might not be true. So you need to verify, and you need to verify continuously, because with the cloud native model of building, shipping, and deploying applications, you are running, you're making changes to your deployment environment continuously. You're running pipelines, you're using GitOps tools to go ahead and apply the changes to your production. So there's a lot of need for us to include the resilience testing or the validation aspects into your standard pipelines. That means you need to automate experiments. The principles of chaos, which is a set of practices around how you should do chaos engineering, recommends that you automate experiments to run continuously. And exploratory, freestyle, manual, game day oriented execution of chaos is probably not the only way to go, though it is one of the important things to include in your process of chaos engineering. But you also need to run it continuously in an automated fashion in your pipelines. And when you look at running chaos experiments, chaos engineering is not just about fault injections, it's a lot about observability as well. You need to validate hypotheses around your service level objectives. So typically, as services that provide some end or some business goal, you have some SLAs, which are then broken down into individual service level objectives for the different components or services that you have. And you have indicators, service level indicators, that are telling you whether, that are giving you the raw information around how a particular service is behaving. You can define cutoffs against them, what we call as SLOs. And validation of these SLOs goes hand in hand with the process of fault injection. So chaos engineering is both injection of faults as well as verifying what happens when you inject those faults. And coming to the way in which chaos engineering is being practiced, or the actual functional aspects of chaos engineering, we live in a declarative world. Everything is defined in YAML in Kubernetes world, right from your applications, their lifecycle management. We provide resources, you define policies around security, etc. And we want resilience also to be defined that way. So you want your chaos intent as well as the steady state hypothesis available in a declarative configuration, that is as YAML, and in the Kubernetes world that maps to resources. And since we can have custom resources in Kubernetes, we can extend the basic Kubernetes functionality with a lot of intelligence around chaos engineering using custom resources. So Ritmos is an open source platform, a project which is in CNCF sandbox today, and it is used for practicing chaos engineering in a highly scalable way. It provides you an end-to-end platform doing chaos engineering, and it is growing with a lot of contributions from other organizations. And we have some of these concepts, providing an open ABI to define the chaos engineering experiment, a standardized way to define an experiment, hooking up with GitOps tools to do chaos as part of a GitOps flow, providing observability hooks to generate metrics, also verify metrics from the ecosystem around you and factor that in as part of your experiment validation, etc. So these are the cornerstones on which Ritmos is built. And we have integrated with Keptn, which provides you a way to orchestrate your application delivery process in an autonomous, automated way, with Ritmos being used to implement what are called chaos stages to verify whether your application is resilient enough to certain faults, whether the SLOs are being met before you actually take it and move it into the next production environment. So at this point, I'd like to hand it over to Juergen to talk about the integration and what is the Keptn project about and how we've integrated. Over to you, Juergen.
Thank you, Karthik. So we've heard now about chaos engineering, and in this part, I want to briefly introduce Keptn, which is a cloud-native application lifecycle orchestration tool. It's also open source. It's also in the state of a CNCF sandbox project right now. And this tool is really for orchestrating your already existing tools in your continuous delivery workflow, but also in automating parts of your operations. Today, we really want to focus on the SLO-driven multi-stage delivery part. So that means we are going to use SLO-based quality gates to either promote the service from one stage to the other if it's resilient, or hold it back, or even roll it back in one stage if the service is not resilient to the chaos we are introducing. And we're also using this to introduce the chaos, to trigger chaos tests next to the performance tests that we already have in our applications or in our delivery workflows. Again, it's declarative, it's based on GitOps, it's extensible, it kind of also fulfills everything that you would suspect from modern tooling in today's world. So let me just move on here to the next slide. Here we go. So at the core of Keptn, let's say, there is the Keptn shipyard. This is a declarative definition of your, let's say, of your project that contains a couple of different services or microservices or applications. So this one is really just a definition of a process and your environment, but it's not a definition of the tooling. So it's very transparent to the tooling. The tooling is actually defined in a different concept, which we call the Keptn's uniform. But the important part here is that whenever you change tooling, maybe you change your deployment tools, maybe you change your testing tools, you don't have to change your environment and process definition. The separation of these concerns, the tooling and the process, is done via cloud events. So integration with Keptn can be done via cloud events. Everything that is sent from Keptn is a cloud event, and everything that is sent to Keptn is also a cloud event. So for deployment, for example, we do have integration with Helm, so we can use Helm as our tool for deployment, but we could also use others like Argo CD or other deployment tools that you might be using. For testing, we do have a couple of integrations like Gmeter, Locust, Artillery, and also Litmus. So these are all testing integrations that would react whenever Keptn is triggering a test. And then we have the Keptn quality gates that are doing the evaluation part, and they are based on service level objectives. So I've only showed you now 3 parts of this delivery sequence. There might be more tasks. These are customizable, these are user defined, but for, let's say, today's topic, these 3 are the main ones that we are going to use. So how to do the quality gate evaluation? As Karthik already explained, we are using service level objectives here. This is a very strong concept to really define the objective of your services or applications based on different service level indicators. So the indicator is basically, let's say, a metric that can come from, and the value can come from any data source. Let's say it can come from Prometheus or other monitoring providers. And in the quality gate, we're using this service level indicator and putting on those service level indicator, we are putting some objectives like the success percentage of a probe, or of a if the service is available, has to be higher than, let's say, 95% within a given time frame, or the duration of the response, like a response time, has to be faster than any given threshold, or even has to be faster than an increase of a couple of, let's say, 5%. So there can be different ways how to define these kind of service level objectives. And then with Keptn, this quality gate can be triggered either via directly in the evaluation as part of the sequence that we've seen in the shipyard, or via the CLI, via the API. There are different ways to trigger this kind of quality gate evaluation. The important part here is that the heavy lifting, how to reach out to the data providers, how to define which data has to be queried for which given time frame, this is all done by Keptn. So Keptn can reach out, query all the data, score the data based on your SLO file, and then give you back a total score. And only upon the total score, Keptn will decide if this new version should move on to the next stage, or if it should be held back or even rolled back in this particular stage. So this is our quality gate, and we can use not only performance metrics, but we can also use service level objectives based on some kind of resilience criteria, like the availability in these quality gate evaluations. So having this quality gate, let's now put everything that we already heard in this presentation together. So we do have Keptn that will orchestrate our whole tools that we're going to use. First, we are going to deploy our demo application, which is, in this case, in the demo we have prepared for today, is the potato head application, and we are going to deploy it with Helm. So Helm will be triggered to start the deployment, and once it's finished, Keptn will move on in the next task in our delivery sequence, which is to trigger the tests. And in the in this integration, we have not only locust tests that send some load against our test application, but we trigger at the same time also the Litmus integration. So Litmus will start to execute chaos on our application on the test, and both the load and the chaos will be executed at the same time. So we can make sure that we really evaluate something under real world conditions, so to say. Once the load and the chaos is finished, we are triggering the quality gate. Keptn will reach out to Prometheus, fetch the data, and then start the quality gate evaluation. And based on the score, it will give us, let's say, a high score and a thumbs up to move it to the next stage and to decide the resilience of this application based on our service level objectives is high enough. Or if the score is not high enough, that's an indicator for us to go back and improve the resilience of the application, either by changing some configuration or redoing some, fixing some bugs, or whatever the issue was. We can see which of our service level objectives would fail. So before we are going to see how the whole run through in Keptn by triggering all these different tools is, I will, Karthik, let explain how we built the demo and which moving parts are included.
Thanks, Juergen. So whatever Juergen just explained, with all the tools coming together, it is all defined declaratively, the stages being defined in the shipyard. The Ritmos experiments that are run are also available as a manifest, a custom resource that can be maintained in Git and triggered by Keptn. So with this diagram, we're trying to explain the demo environment and the flow of the experiment itself. So we have the potato head application, which is basically a microservice application from CNCF. And we are basically trying to load it with locust. There is a tool that's trying to continuously push some load here. And we've got the Litmus service running in the Keptn control plane, which is capable of injecting chaos against the potato head application. And for the purpose of this demonstration, we're going to make use of the pod delete experiment, which is traditionally the hello world test in the chaos engineering world. So we create a graceful pod delete of the potato head service. And we're basically going to restrict our blast radius to a single replica. So we're going to just kill one replica just once. At this point, we have some observability infra that is making note of whether the potato head application is always alive. So there is a Prometheus installation along with a black box exporter, which is trying to query the potato head app for availability and also for a metric that is basically the access latency. And we have defined in Keptn, the quality gates have been configured with SLO cutoffs against the availability and the access latency. And we are going to do this chaos run as soon as the application deployment finishes. It's going to be load and also the chaos running at the same time. And when we are going to do this experiment, we're going to do it in two phases. First, with just a single replica, so you expect that the SLOs are not met. And next, with more replicas, we apply the remediation and do it with more replicas. And this time, we see that despite one of the replicas being killed, we still see that the SLOs are met. So this is a suboptimal deployment that we're making use of to illustrate how chaos and CD can help you. With that, I think Juergen, you can explain the actual steps involved inside of the demo process.
Yes, thank you, Karthik. So we put in here a couple of screenshots, and since a live demo would take a couple of would take too much time, and but we will see each of the steps, and it's just a cut demo. You can think of this to save some time. So it's a first step. We trigger the delivery sequence. We've showed the first part is to really deploy our demo application. So we trigger a delivery sequence that has the deployment, the test, and the evaluation as the 3 tasks for the deployment. So as we can see here, deployment was finished within a minute or so, and then Keptn triggers both the Litmus and the locust service at the same time. And after a couple of minutes, both services indicate that they have finished the job. So in this case, the Litmus chaos was the first that chaos tests have been finished. The locust load was running for a minute or so, a little bit longer. The important part is that since Keptn triggered both integrations, Keptn also knows when have the tests started, when have they finished, and can then move on to the evaluation phase. So you can also think of this as a longer running experiment, maybe for 1 hour, triggering different kind of test integrations. But after the tests are finished, Keptn would evaluate for exactly this one microservice, would evaluate the data or the resiliency based on the service level objectives. So in this case, the evaluation is going on and resulting in a score of 0. So we could not fulfill our service level objectives. Having a closer look at the quality gate evaluation, we can see that we have only two service level objectives here. They are mainly checking for the availability of the microservice and also how fast it can respond to the probes that we are doing via the black box exporter. So we can see that the availability of our application, so to say, was only around 70% of the time during the test time frame, and the probe duration took a little bit longer since the app also had to start up, and it was kind of a cold start, and the first requests took a little bit longer. So in our second run, what we are doing is to increase the replica count, as Karthik already explained. And with a higher replica count, we would assume that if one of our replicas, one of our pods in our replica set is removed, the other 2 pods are still able to serve the traffic. So again, we are running the same sequence, just with a little bit of different configuration. Keptn is triggering, again, the same tests. This has to take about the same time, but this time we are getting a positive evaluation. Again, taking a closer look at the quality gate evaluation, we can see that both the probe success percentage as well as the duration now are within our service level objectives that we have set. So for the probe success percentage, we even got 100%, so the app was available, and the duration of the probes was also very, very satisfactory. So it was just 2 different service level objectives that we have defined, but they could already indicate if our application is resilient, and a replica count of 1 is not resilient to maybe an infrastructure outage if the node where the pod is running is probably going down. So we need a higher replica count, maybe even distributed on different nodes. But what we tested was if one instance of our application goes sideways, then we could not meet our service level objectives anymore. If your service level objectives are a little bit lower, you might be able to still satisfy them. It really depends also on the needs of your organization. So the key takeaways for today is we really want to advocate for establishing a process of continuously evaluating resiliency. There is, we have already heard, there's this practice of testing in production, and I think it's a very good thing to do, but also moving this already into earlier stages can really help you to improve also the resilience of your applications, because you can test it before you move it to production, and you can already identify some issues. Some issues you might only be able to identify in productions, but some issues you can already identify in earlier stages. And having chaos tests in addition to performance tests can really help you. I think those two really have to work together. So just having chaos without any good performance and load tests won't give you the highest benefit, but combining them is really a very strong method. And the evaluation of the resiliency should be based on service level objectives. These have been have proven as a very strong means to evaluate quality criteria like response time, some kind of availability objectives, and everything can be based on service level objectives. What we've shown today is actually already adopted at a company called GitOps. They are using Keptn to orchestrate the process and also for the evaluation based on service level objectives. They are using Litmus for injecting some load. They do have different stages of let's say, the severity of chaos. So they expect to survive light chaos, how they call it, and they expect also to fail heavy chaos. So they are well aware that they cannot come up with an application that survives 100% of any chaos, but they need to survive what they call a light chaos scenario, where a couple of nodes maybe go down, but they are well aware if everything goes down, they cannot survive this, or they cannot meet the service level objectives. And they are also kind of using this as a counter example that they know the service level objectives are not too strict or not too relaxed. So with this, I think this was already more or less the last slide. So with this, we leave you with a couple of resources. If you want to give it a try, go to litmuschaos.io or keptn.sh. Those are the two project websites. You will find a lot of resources there. We even did a two-part blog series on this topic. You will also find the links here, or you can just search for the blog on Medium or DevTO. And we're also happy to welcome you as new followers of the project or of our private accounts. So I think now with this, thank you very much. Thanks, Karthik, and see you all in the Q&A.
Thanks, Juergen.
So I think if I get it correctly, now the Q&A starts, and we have a couple of minutes for Q&A. So thanks everyone, first of all, for watching this session and for all of the questions that you already put into the chat and to the Q&A section. I'm not sure if we get any kind of reminder when Q&A ends, but I will just take a couple of questions that have not yet been answered in the chat. And the last one was from Sudeep. And the question is, can Keptn be used for multiple Kubernetes cluster lifecycle orchestrations? And yes, that is possible. So you will have the Keptn execution plane running in one of your Kubernetes clusters, and then you can connect from any other Kubernetes cluster to this execution, to the control plane, and then have the execution planes running also on different Kubernetes clusters. And I will also put a link to this into the Q&A section. And I also see Karthik joining. Hi, Karthik.
Hi, Juergen. Great to be here. I hope you all had a great time in the session. There were a couple of questions around chaos, around whether it can be used in production or how you can extend chaos tests. I hope the questions were answered by yes. You could run chaos in production. There are the hooks in Litmus that can help you to stop if things you feel are getting out of hand. If you want auto aborts, you can also control blast radius and ensure that you're targeting only those application services or infra components that you wish to. And chaos in production is really something that is recommended, but you could start small, running it on development clusters, test clusters before you go ahead and do it on production. And you could use the chaos resources like Juergen just mentioned. They're stored in the Keptn internal Git store and triggered automatically. You could store multiple chaos engines. The chaos engine is the declarative manifest that carries the chaos intent. So you could create multiple chaos engine resources. with the fault of your choice, the fault having been picked from the Ritmos Chaos Hub. So that's how you can extend your chaos tests and run it along with Keptn.
Great. I think the session is already scheduled to end in around 30 seconds. So I would suggest if you have any follow-up questions, you will find us in the CNCF Slack and Kubernetes Slack, or on the different website projects. We also have all the contact information, how to reach out to us and learn more about the project for LitmusChaos or for Keptn. And I guess we're happy to follow up later on also with you to answer any more follow-up questions. But thanks everyone for joining, and have a great rest of the CDCon 2021.
Thank you. Wish you a great conference.
Thanks everyone. Bye.